Good morning, everyone. I'm Ramakrishnan, and I'm the Datacenter Performance Director. I'll be talking to you about performance on the third-gen Xeon Scalable platform for the next few minutes. You've already heard from Thor, about the Xeon Scalable platform and all the different components, and Irma walked through some of the architectural details in the previous section. But before we start deep diving into performance itself, I wanted to recap some of the key changes that are coming about with Ice Lake that have a strong influence on the performance side of things. So first off, from a core standpoint, we now support up to 40 cores, going up from the 28 cores we had on Cascade Lake. And there are a lot of improvements that Irma already talked about with regards to the Sunny Cove core. There are also architectural improvements from a cache standpoint, basically enabling a lot more consistent and low latencies for our local cache as well as the remote socket accesses. So these are things that, every small bit adds up, right? So this is an important piece, from just the core and the cache architecture side. When we look at the memory channels, we used to have 6 channels on Cascade Lake up to 2933 memory speeds, but Ice Lake goes up to 8 memory channels and 3200 memory speeds. And this is a big boost in performance for a lot of workloads that are memory bandwidth dependent. The socket-to-socket interconnect has also gone up for intersocket speeds of up to 11.2 gigatransfers per second. And from an I/O standpoint, we now support PCIe Gen 4 on Ice Lake, which will allow 2x the bandwidth compared to the Gen 3 lanes that we had on Cascade Lake. In addition to that, we are also increasing the number of lanes from 48 on the previous gen to 64 now. And we have a lot of workload acceleration pieces and instructions. We've had it in the prior generations as well, but in addition to things like AVX 512, VNNI, DDIO, we're adding some of these new crypto and security capabilities that add additional value to our customers. And lastly, we talked about the Gen 4 devices and the Optane persistent memory. These are some new capabilities that will enhance the performance of the platform across different usage models. So all of these come together from a platform perspective and making it an ideal scenario for different types of customers, whether you're doing networking kind of workloads, storage workloads, or compute workloads. I wanted to start off by sharing some of the standard benchmarks. You can see over here we have spec int rate, which is the integer throughput, spec FP rate for floating point, memory bandwidth with stream triad, and linpack. And if we look at it gen on gen, comparing with Cascade Lake's 28-core processor that we had, we see about 50% gain on integer, 52% on floating point. The memory bandwidth is up 47%, and the linpack is up 38%. At an aggregate, that's a 46% improvement in performance going to the prior generation on these standard benchmarks. We also have a large number of customers who are on platforms which are much older, and which platform they are on depends on the type of customer they are and the market segment they might be in. Some of them are on Skylake with the 8180, where we see up to 54% improvement in performance. On Broadwell, customers upgrading from there can see an aggregate of 2.65x improvements. Or if you look at Haswell, it's all the way up to a 3.1x improvement in performance. So across the board, depending on whichever platform you are and you're upgrading to Ice Lake, we have a pretty solid performance story on the basic standard benchmarks. In addition to getting those benefits that I showed you in the previous page, which is through adding cores and some of those optimizations, there are a lot of these built-in acceleration features that we have continuously been adding across our product line over time. And these are things that bring real value for a lot of our customers. DDIO has been around for a long time, but it is still invaluable to customers who are doing, in the networking space, doing packet processing kind of workloads. In this case, with the feature turned on versus off, for a L3 forwarding type of a workload, we see up to a 30% increase in performance. AVX 512 was introduced with Skylake, and compared to an AVX2 implementation, we see up to a 60% improvement where a workload like Linpack can take advantage of that vectorization and improve the throughput that we get out of these processors. Skylake, Irma talked about this with the new crypto instructions on Ice Lake. We can take advantage of these capabilities along with the software optimizations that might be there with multi-buffer capabilities that are there, and this could enhance the performance of an Nginx type of a workload by 4.2x. So I think Tim had this question earlier. And this is a pretty sizable increase in performance when we are looking at connections per second running Nginx TLS workload. Okay. Lastly, DL Boost. This is the capability that was introduced on Cascade Lake, and we continue to support it. And simple look at it, when we go from FP32 to int8, we can see up to a 4.3x increase in ResNet 50 inference performance on the same processor. So these gains are pretty substantial in terms of what one can get from just adding cores and so on. This is additional value beyond that is available through these acceleration capabilities. And as customers start to adopt these and use these, they start to get more pervasive. I wanted to share, ideally, if we had time, we could talk about performance like for a couple of hours if we had. But I wanted to summarize some of the key areas, right, on how performance stacks up. And the data center is a pretty complex area comprising a large number of workloads. Given the shortness of time, I tried to pick a few representative areas that are pretty common across different usage models. From an infrastructure standpoint, it is important to look at ensuring great performance, not just from a cloud standpoint, but also for on-premise enterprise type of situations. And virtualization is one of the important workloads over here where the quality of service is an important metric. And with the new architecture, the memory bandwidth improvements, the Gen 4 PCIe capabilities, we're able to take the entire platform and see up to a 72% improvement in performance compared to the prior generation. From a networking standpoint, I touched upon DPDK-L3 forwarding. When we look at this generationally, we can see up to an 88% improvement in performance as we try to move packets within the data center and beyond. So these are important things to keep in mind from an infrastructure standpoint. For many web workloads, response time or responding to queries within a given service level agreement is important. And Irma alluded to this when she talked about how when we are architecting these products, we are looking at not just the raw throughput that we can get out of these things, but how do we do it in a way where we improve the latencies and things like that that could make the experience much better for our customers. So a couple of workloads shown here. One is a web microservices workload called Cloud Expert. In addition to the architecture, it also takes advantage of some of the AVX 512 capabilities as it is doing some analysis with options suggestions to its customers. So that workload takes advantage of some of the AVX 512 capabilities that can boost the performance. Java throughput, very popular for retail type of use cases and so on, where there's a request and response kind of a scenario, and having a response within a certain SLA is, again, as I mentioned, extremely important. Here we are seeing up to a 62% improvement coming from the core, the cache, etc. Staying on that note, database is a pretty dominant area. There are different types of databases, both commercial as well as open source. In this case, with the MySQL database, we are seeing up to a 64% improvement in performance. This tends to have some I/O transactions. It tends to have the compute part of it in the core. All of these are helping with that performance. And then lastly, data analytics. There is a I/O component over here, which is important as we look at the different pieces of data and analyze it and come up with a classification of particle physics, as is the case of this workload. And we see a big solid 65% gain over there. Another interesting area in the data center market is the high performance computing side. And here again, workloads are very diverse, and we'll touch upon this in a more detailed slide. But in a workload like weather forecasting, which is bandwidth intensive, we see a 58% gain, while on a financial services type of a workload, which is heavy compute intensive, you will see up to a 70% gain compared to the prior generation. We already had a detailed conversation about AI earlier this morning, but taking advantage of our VNNI capabilities with DL Boost, to 66% doing image recognition and 74% doing language processing are some of the gains that we are seeing over here. So across these wide range of usage models, you can see that Ice Lake is clearly shining across multiple aspects of performance, and it's the platform that is coming out cumulatively over here. What is even more exciting, and this is a build from the previous slide, and I wanted to share this because we are seeing gains from a raw throughput standpoint, but when we look at it at a core level, what are the gains that we are getting? You can see some pretty exciting numbers going, from 10 to 40%. And this again goes back to there was a question earlier about how do we see performance across, IPC and so on. It varies, right? There are different elements to different workloads, and how much you get on a per core basis might vary across all these different use cases. So in some cases, with some of the new additions to the platform and the capabilities in the processor, you're seeing some pretty solid gains from a per core basis. And these gains, again, right, when you're looking in virtualization environments, etc., they are like step function gains that we are seeing in terms of performance, which are definitely going to be exciting for our customers as well. Given the limited time, I wanted to touch upon a few areas and segments, and the first one I wanted to start off with was in the storage side. Storage, as we talked about earlier, there are multiple algorithms that are there, whether you're doing error checking, data encryption, compression, and so on. We alluded to some of the accelerations that are coming with Ice Lake, and some of those, like CRC, we see up to a 2.3x gain when we are doing a per core performance comparison versus the prior generation using intelligent storage acceleration libraries. This is essentially a big boost for things when you're doing error detection in order to maintain the data integrity of your storage subsystem. Encryption side, we see with AES XTS algorithms, we are seeing up to a 3.5x gains. And when our customers can take advantage of these things, again, going back to the question that Tim asked earlier, when we look at these standalone, it's these large numbers, but the deployed solutions, you might see different mileage, because when you're doing this continuously, you're probably going to see this. But in a real application, you can take advantage of this and improve that performance, but it will not. It will still be a positive gain for many of these storage solutions that will be there. Moving from just the core perspective to looking at some of the newer emerging models, the middle of the page is an example of an NVMe over TCP scenario. This is essentially an evolution of NVMe over Fabric for a disaggregated solution within a cloud, or whether it's on-premise or public solution. This whole setup enables us to provide a low latency shared storage solution while reducing the design complexity with the use of standard Ethernet. In this scenario over here, you can see that there is the new PCIe Gen 4 devices, both from the NAND SSDs as well as the Optane SSDs, as well as using the latest Gen 4 NICs, we see a solid 2.7x gain in IOPS compared to the prior generation when we are doing 4K mixed read-writes. Okay. On the right-hand side is another example I wanted to share, which was with regards to the Intel Optane persistent memory. Aerospike is a database that has been optimized to take advantage of the Intel Optane PMEM capabilities. And in this case, on the left-hand side, on the dark blue bar essentially shows you a scenario where Cascade Lake is using Aerospike, where the index for the database is in persistent memory and the data is in the SSD. When we move to a similar scenario with Ice Lake, we see about a 43% gain in performance. But what is even more exciting is when we have the larger memory capacity with up to 8 terabytes of just the PMEM, we are able to not just take the indexing into the PMEM, but also the data into PMEM, and we see a pretty solid 2.5x improvement in performance. So you can see with these emerging usage models and optimizations and things, as they start to proliferate, people can start realizing these larger gains from their infrastructure by taking advantage of these new capabilities that are there. Okay. Let's move to the next page and talk a little bit about networking performance. Thor talked about, we have various SKUs which are networking optimized and referred to as the N SKUs. In addition to that, the other things which come along are the improvements to the core architecture, the crypto capabilities, the PCIe Gen 4 devices, and so on. All of these add up to providing significant performance gains. If we take a few examples, content delivery networks are pretty popular, and when we are doing live CDNs, we can take advantage of the PMEM capabilities for the larger memory capacity, as well as the Gen 4 NICs to get up to a 63% improvement in performance. When we're doing packet processing workloads like VPP, forward information base, or which is both a router as well as a forwarding function, or if you're doing just L3 forwarding type of workloads, see about 66% and 88% gains in performance on these scenarios. A couple of other interesting ones are the cable modem termination system, CMTS, where we take advantage of the vector AES capabilities and can get up to 72% gains with the new Gen 4 devices. And then on IPsec, again, taking advantage of vectorization with both AES and the carryless multiply, we get up solid 94% gain. So depending on the type of workloads, the gains vary across the different levels, but you see a pretty good increase across the board, with an average of up to 62% on the third-gen Xeon Scalable platform.
So the encryption, decryption, that's all happening right on the network card itself. It's not being sent elsewhere in the box, offloaded to some other processor. It's all right on the card.
The card is not doing it's the CPU that is handling, some of the cores are handling the encryption, decryption. The card is basically the bandwidth that you're getting in terms of improvements.
Okay, that's what I was wondering about. If there's any other features that these network cards are doing on board, or if they're just basically the fat pipe to shove your packets through, and you're relying on that PCI 4 bus to get it to the other systems that do the other processing.
Yeah, in this case, it's just a fat pipe. But you bring up a very important point, which I probably I would have forgotten if you hadn't brought this up. The Columbiaville cards are 100 gig cards, and the new 200 gig cards that Thor introduced earlier also have a couple of interesting capabilities. One is called the ADQ, Advanced Device Queues, and this allows us to channel an application to have a dedicated amount of bandwidth. So what this does is it helps reduce the amount of jitter that might be there and have a constant throughput in what you can receive for certain applications. So that's one of the interesting capabilities that Columbiaville offers. In addition to that, there is a different usage model called DDP, Dynamic Device Personalization, And DDP has this, in networking, you have so many different protocols that are constantly changing or evolving. So you can add that level of acceleration into the device itself. You can program it and take advantage of the capability to speed up some of the things like you just mentioned. In this case, we haven't done any of that. We are just taking advantage of the cores to do the vectorization and speed up over here, and the bandwidth for the pushing as many packets as possible. But we do have that capability with DDP to capture some of those newer protocols that might be there to speed up that within the NIC itself.
Is that making those changes, is that through the one API, or that's some other piece of software that you rely on to make those changes?
I do not have the answer for that, but we can check and get back to you.
No worries. Thank you.
Yep. I touched upon HPC a little bit earlier. Wanted to quickly share, HPC-like networking is pretty diverse. You have so many different usages and workloads that play over here. It's the type of compute that is driving this stuff. But again, you have two elements over here. One is a bandwidth intensive workloads. Weather forecasting falls in that category, where when you the increased memory channels and the core improvements, those drive a big improvement in performance of here of up to 58%. On other workloads like the financial services, we see a range from 28 to 70% improvement in performance, an average of 53%. These are compute heavy. Some of these take advantage of AVX 512. And so that gives us that additional boost that you're seeing here. On the manufacturing side, something like OpenFOAM, we're seeing over 50%. And then similarly, life and material science usage models, we see 57 to 64% gains. So across the board on HPC, there are a lot of positive things that Skylake platform brings to the table, be it the core enhancements, the cache improvements, AVX 512, 8 memory channels, and PCI Gen 4. All of these come together well for many of the HPC codes. Okay. The next slide, I quickly wanted to also touch upon AI. This is an area that just continues to keep going at such a fast take. In addition to existing workloads in the data center, customers can take advantage of the built-in AI capabilities and start looking to unlock the business value by deploying some of these and getting more insights out of their solutions. There are two categories over here, machine learning and deep learning. On the machine learning side, there are a vast number of algorithms. If you look at scikit-learn or XGBoost, within that you can do a lot of things in the machine learning space. I just wanted to throw out a few things. XGBoost, it's pretty. It's a decision tree based, machine learning algorithm, and it's used for a large number of data science users. And we see 44 to 30% gain there. K-means, this is a clustering algorithm. It's used for things like detecting anomalies, classifying sensor data, inventory categorization, all those things. Again, 36 to 44% gains on this. And then linear regression is probably one of the most commonly used algorithms, and in this case, we see up to a 60% gain when you're doing an inference with it. The deep learning side here, and in the machine learning side, there are a lot of optimizations that we have done with Intel Python, et cetera, that help give this boost. Thor alluded to a 100x gain. This is when you take the stock solutions of scikit-learn, et cetera, versus a optimized solution that can take advantage of the parallelism and so on. You see these spectacular gains in performance, which you will not get with the stock solutions that are out there. Deep learning side, we already talked about the over 4x improvement when you go from FP32 to Int8 when doing like a ResNet 50 kind of a thing. But there are other usage models, be it image recognition, language processing, and so on. And across all of these, there are some pretty solid gains where when we look at VNNI and take advantage of that, the throughput that we get out of these instructions is pretty solid. And when we look at an FP32 versus Int8, these numbers, become a lot more material in terms of orders of magnitude of improvement. So continued improvement with AI as we move forward with this platform, and it's very exciting for us. So last slide, I just want to touch on quickly. We've touched upon a lot of different things over the past hour, and we're super excited about the third gen Xeon Scalable platform, both from a performance and a performance per core standpoint. And we saw this across a broad range of workloads that fit within the data center. We talked about built-in acceleration and these new instructions that are helping our customers across multiple segments, be it AI, HPC, networking, cloud, etc. And then lastly, we have a very highly competitive portfolio that will help our customers across a variety of segments as they move, store, and process data. And last but not the least, the ecosystem behind us is pretty solid. We've talked about the select solutions. The capabilities that it brings is advancing our customers to be able to adopt these solutions much faster and get them to a known good state much faster so that deployments on the new generation can happen much faster. So all of these things bring real value to the end customer. We are super excited by it, and we believe our customers are looking forward to this as well.